Example 8.2. In that second question, that is sin omega t plus cos 2 omega t plus sin 4 omega t. And it is example, it is also example for periodic motion. It is also a periodic motion because every sine and cos function is a periodic motion, but here every term oscillating, okay, every term is oscillating with different frequencies. Okay, so it is having only one frequency and it is having two frequency, and this is our having four frequency. But system means combination of these three is a periodic motion. Okay, so that periodic motion is nothing but it is the we have another definition, that is the shortest time taken by the particle to complete one oscillation. Okay, the shortest time, the shortest time taken by particle to complete one oscillation, is time period t. Okay, this is our time period. Then here if we are observing this term, individual term, okay, that is sin omega t, time period of this term I am taking, that is sin omega t only. Okay, so in this one, so here we have it, that is omega. This omega is equal to omega. So in this omega place we have only one omega, and that is equal to 2 pi by capital T. From that T is equal to, that is how much, 2 pi by omega. This is the time period of this term only, that is sin omega t. Like that, time period of cos 2 omega t, cos 2 omega t. So here in place of omega, we have a 2 omega, that is equal to 2 omega, and that is equal to 2 of this omega, we can write here 2 pi by capital T. Okay, so that is equal to, sorry, this is not 2 pi. Okay, this omega is equal to, this is 2 omega, and this is equal to, we can write here 2 pi by capital T. So 1t cancel, and this is equal to, capital T is equal to pi by omega. So this is pi by omega. This is the time period of what cos 2 omega t only. Okay, like that time period of sin 4 omega t, sin 4 omega t. So that is equal to, in place of omega, now we have here how much, 4 omega, and this omega is equal to, we can write 2 pi by capital T, and this is equal to 4 omega. 1 2 1 2 cancel, that is 2 2 are. So from this, capital T is equal to pi by 2 omega. This is the time period of sin omega, sorry, time period of sin 4 omega t. So actually, so which one is the smaller and which one is the bigger here? Okay, so for suppose if you are observing like this, okay, so there is a one graph I am taking here for this all. Okay, so this is our one oscillation. For suppose this is sin omega t. Okay, for sin omega t, this is the it is 0 time, this is t by 4 time, and it is our t by 2, and 3t by 4, and this is our what, capital T. So sin omega t, it is started from the 0, means we got the like this. It is taking one complete cycle in one time period. So here the time period is, for suppose we are taking time period is t naught or something t. Okay. So in one time period, it is repeated after this. So that's why up to here it is the one time period for sin omega t. But for this cos omega t, cos 2 omega t. So cos 2 omega t, it is already, it is means it here the sin, for sin omega t, it is the frequency, this is one only, because it is completed one cycle, but it is completing two cycles. So that's why this is for suppose our cos is started from here. Sorry. This is one cycle. So it is from started from here, and 0 and negative and 0 and positive. It is completed one cycle up to here, and then after this like this. Okay. So then last one, this is sine 4 omega t. So it is like this. This is one and 2 and 3 and 4. Okay. So if we are observing here, so it is oscillating with frequency 4 up to year 1, then up to year 2, then it is 3, and it is 4. Okay, that's why its frequency is 4. So by this diagrams we can understand that total system. Okay, so within the one time period, it is completed one cycle only, it is completed two cycles, and it is completed four cycles. But after this time period only, okay, the total all these are repeating the motion. Okay, it is repeated by one frequency, it is completed two cycles, but repeating after this, and it is also, it is completed four cycles, then another time period, so it is completed another four cycles, another time period, it is completed another four cycles, like that. Okay, so after four cycles, after four frequency, it is repeating its motion, and it is after two cycles it is repeating its motion, and it is after one cycle it is repeating its motion. So after which time period the whole system will be repeating. Okay, after which time it is repeating. Okay, so this is the time period. After one time period, all systems are repeating its motion. But here, if you are observing here for this cos 2 omega t, this is cos 2 omega t. So here it is completed one cycle up to here. Up to here it is one cycle is completed. Means it is also we call here time period for this one. Cos 2 omega t, it is one time period. But at this time period, this motion is not repeated. It is completed only half of the cycle, and it is also completed two more cycles, but this is not repeated. So whole system not a periodic motion up to here. So then if you are come to here, so this is the one time period. This is we call here one time period. At this time period, it is also not completed one uh, a cycle. So that's why it is not periodic motion if you are considering up to year time period. So that's why here whole system is repeated. When it is completed one cycle, then it is also completed, and it is also repeated its motion by frequency 2, and this is also um, repeated its motion by 4 frequency in that one time period. So whatever the shortest time period, after that shortest time period, whole system is repeating, and that period is nothing but here time period. So this is the time period. The time period is the sin omega t, that is equal to how much we got here, that is t is equal to 2 pi omega. So whole system time period time period of system, that is t is equal to 2 pi omega. After this time period, every cycle is repeating its motion. This is second question.